Good morning, everybody. Good morning, everybody. Aloha. I didn't hear it back. Aloha. Very good, very good. Good morning. Thank you for coming out at such a early hour and after a lot of festivities last night, no doubt. I'm Doug Cunningham. I'm the Chief Executive Officer of Arctic Fibre. This is our third breakfast at PTC. We have had a great turnout. Some of you have been here before, some of you are new, so I'm going to take the opportunity to introduce the expanded members of our team that are present today. Mike Cunningham will address you later on. Mike is, yes, he's related to me. He's my father. And he's actually the brains of the operation now. It's hard to admit, but he has got better skill sets in the area than I do. Elizabeth Pierce is the Chief Executive Officer of Quintillion Networks. She has been to all of these places that we were showing here on our slideshow earlier, having worked 14 or 15 years in Nunavut as a technician, and she has her engineering degree, and she's done an absolutely crackerjack job of bringing in the business in Alaska. And at the back of the room is Hans Roderink, and Hans is the Chief Operating Officer of Quintillion Networks and assisting us with the technical aspects of our build. We also have at the back corner two other people who have been great supporters. Wayne Nielsen in the green shirt. Most of you would know WFN Strategies has been our technical consultant, and they will be helping us with the project management and implementation of the project over the next 2 to 3 years. We also have representatives from TE Subcom, Dave Robles and Mike Rieger at the back. TE Subcom has done a lot of engineering work for us, and two of their personnel have done the great trek across the north last August and will be doing so across Alaska in the coming months. I don't see Peter Phibbs from Leadcore. Leadcore has also been one of our partners and will be doing a lot of our civil work as we go forward. Since last year, which button do I push here? Oh, there it is, right there. This map has changed a little bit since last year. There have been a number of changes, principally in our landing points. We had initially been going to go into Mariama Bay. We have shifted that up to one of two alternatives that we have at Ajaguara, and that is to take away some of the distance that we would have had on the network and shorten the network up. Also a more direct route into central Tokyo from there. And still, while we're on the Japanese side, we are building a branch into Tomokamai, and we'll go into that in a bit. Over on the other end of the network, in response to customer demand, we have moved into Cork in Ireland, so we'll be putting a spur off into there. That will enable us to serve content data networks delivery networks who are building data centers and cloud computing facilities in Ireland. And we have shifted our landing point in England up from Bude to Highbridge, again to ensure better physical resiliency in the network and to shorten the distance a bit. The Canadian landing points there are intact. There have been 1 or 2 extra communities added in Prudhoe Bay that Elizabeth will go into. And what is, I think, a bit more of a definitive line is down from Prudhoe Bay into Anchorage, where the Dalton Highway, familiar to some of you who watch Discovery Channel as the Ice Road Truckers Highway, there is a fiber build that's being built, led by AT&T, and we will be one of the key anchor tenants on that system. And then we'll use existing fiber to get from Anchorage to Seattle. The other element here that Mike will talk about a bit is doing what we call the North Pacific Loop. This is actually the last island. This last dot here is Attu Island in the Aleutian Islands. Shemya Air Force Base is there. Just before that, at our branching unit, we will be building across, following the existing line into Seattle, and that's Unalaska. So those people who still watch the Discovery Channel, that's where the dangerous catch comes from. And so that's our basic network changes at this point in time. We have pretty well solidified everything. We've been responding to what I call a lot of customer demands in order to do it. For some of you who didn't and weren't aware of it, no need to scribble notes here because we will be providing the slides on our website this afternoon. We can send you hard copies if you wish. I think the key to remember here is that when we go back, these maps make it look pretty long way between Tokyo and Europe. And quite frankly, it's a lot shorter. This is a map that I hate because my printer kind of elongates everything to make the it fit the page. But if you look at it on a circumpolar view, and all of you have flown over the pole one way or the other, it's much, much shorter to go from Ajigawa, or Tokyo, to London on this route. It's approximately 15,300 kilometers, as opposed to over 22,000 kilometers if you went Tokyo, Los Angeles, Long Island, London. So that's the difference for us, is a shorter network equals lower capital cost and lower latency. One of the other elements that was always of great concern to some of the people was the survivability of this. A lot has been made, particularly by our satellite competitor in Canada, about the safety of the network. It is probably going to be one of the safest networks in the world. When you consider that upwards of 78% of cable incidents are derived by human influence, i.e. fish trawling, ship anchorages, or sabotage, we're eliminating most of those on our route because there are very few people up there, number one. And the RCMP and the Alaska State Troopers knew who the bad actors are. Number two is that there's very little fishing activity up there and virtually no ship anchorages that would impact our network route. The ice element, we have designed for it. We've spent a lot of money on ice scour studies, and we've had the Tyco people and the Leadcore people go across to 8 different landing points in Canada and 7 across Alaska. And in most instances, we will be doing horizontal direct drilling to get below there. Bear in mind that since early 1980s, we've been extracting oil off Prudhoe Bay. Again, a very harsh condition in the Beaufort Sea, but there have been no issues with the pipelines because they're buried 2.7 meters into the seabed, and the deepest ice scour that you get is someplace in the neighborhood of 1 or 1.1 meters. Similarly, the other well-publicized incident was off Greenland, and we get asked that question, so I'm going to preempt it. Yes, we cross Iceberg Alley, but we cross Iceberg Alley at a depth of between 600 meters and 3,800 meters. We're far, far below the deepest tail fin ever recorded by an iceberg. It was 550 meters, and that's when it scraped up against the Labrador coast just after the Ice Age. So I think we are confident that we have designed one of the safest networks in the world. We still have 2 basic elements, or 2 basic demand drivers. One is that international market, and the other is serving satellite captive communities in Alaska and Canada. We are also, at the behest of the Japanese government, going to go into Hokkaido, and I would acknowledge the presence here today of Naotoma-san from Cloud Networks. He's here. He can tell you more about what they're doing in Japan, and we'll talk a little bit more about that. So we are providing connectivity between the world's largest financial markets in Asia and Europe. And if you think about on the map again, those areas from Hong Kong, Tokyo, Seoul, Shanghai, that sort of circle there through to London, Paris, Amsterdam, Frankfurt, that pool there, we are ultimately the fastest network. Okay? We are also a direct route between Asia and Europe, and we're providing high-speed connectivity to Alaska for the first time. This is pretty hard to read, but there's been a lot of money and a lot of effort put into this by WFN and by the TE Subcom engineers, just to show you the breakouts. The key part that I want you to remember from this slide is that while we do go into 7 Alaskan communities and initially into 7 in Canada, These are connected by underwater branching units. So it's not a festoon system. The backbone does not go into most of those communities. The only place that we do have a landing in an ice-prone area is at Cambridge Bay, and that's a very, very sheltered harbor and easy to build into. Again, physically route, we talked about avoiding fish trawling in anchorage areas. We have 2 fiber pairs that go directly between Asia, between Tokyo and Europe, and do not go on U.S. soil. So that's of interest to some people who do not want to be subject to the Patriot Act or potential FCC regulation or taxation. We avoid the politically risky areas, the terrestrial crossings in Egypt. And one of the things that is most apparent from last year is post-Hurricane Sandy hitting New York, there were some interruptions, more so created by the terrestrial side of the landing stations on Long Island and New Jersey as opposed to the subsea. But what that has done is lets a lot of the network operators are looking for physically diverse routes. We're also creating a Hokkaido-Honshu route. And we are helping the Tokyo and the Japanese domestic network improve its network resiliency and improve the domestic capacity between Hokkaido and Honshu. And cloud networks, people can tell you more about that afterward. Latency, we've refined all our routings based on the marine work that we've done this year, and we're 153.3 milliseconds between Tokyo and London. We are the lowest latency route from London to Seattle, about 101, 102 milliseconds. We will also be with that other line, the North Pacific loop that we will put across the North Pacific. We will be 79 milliseconds to get from Tokyo to Seattle, and then by extension using other U.S. networks, we will be the fastest route to get into Tokyo to Chicago and into New York. We actually have 2 ways to get to New York in 140 milliseconds. One is via the U.S., and the other would be coming down through Hudson's Bay when we eventually build that out. Our demand factors are ones that you're all well aware of. Internet traffic is great. We're getting a lot of business as a result of cloud computing, and of course, the people have just been absolutely bandwidth starved in the Alaskan and Canadian communities. We have people that just don't understand what YouTube is. They've never had the opportunity. And increasingly, we have these applications that are put up on the wireless things. They just don't work through a satellite feed. They time out. There's your latency table. Arctic route equals ultra-low latency, and we can provide you with those in a hard copy. And as I said, the ones in the green here are where we do have a latency advantage. Some of the ones we don't, but as I said before, generally those in Northeast Asia to Western Europe, we are clearly have a big latency advantage. We have the best of breed partners too. I think that's going forward, that we have an increased size of our management team. We have TE Subcom has done work for us in the past, and we expect them to do a lot more work for us in the future. Leadcore is going to be doing our civil works, and I can't emphasize the need or the difficulty of that in the north. The logistics mean that this year we will actually be starting to do a lot of the staging of some of the drilling equipment and some of the backhoe equipment and putting in beach manholes and doing that civil work in advance of the cable being laid in the summer of 2015. We've had environmental designs done by AECOM Technologies. We've had to file reports that are 226 pages, and in Canada we've had to file them in 4 languages. You thought English and French would get us through, but no, we also use Inuktitut and Inuktitun dialects to communicate with the local communities, and we are expecting our Canadian license in a matter of weeks. And as I said, WFN Strategies has been there. I'm going to turn things over now to the brains of the operation, Mike.
Thank you. I'm Mike Cunningham, and I'm Chief Operating Officer at Arctic Fibre, and I joined the company last November full-time. And it's been a really exciting year because we've had a lot of new developments and a lot of changes, and it's been a really transformative year for Arctic Fibre. And some of these changes were on the network side, where we've had modifications to the network and the different landing points. And I think the real reason why we made these changes is really the market has pushed us in these directions. The new Trans-Pacific route is probably the largest change and modification to the network that we've done, whereby we are essentially realizing a big synergy on our network, where about a little under 3,000 kilometers of our Arctic route is actually shared with the Trans-Pacific route, which enables us to significantly reduce the capital cost of building a Trans-Pacific route. Additionally, with the Trans-Pacific route, it allows us to create a ring around Alaska so that any cut to the main backbone cable there would not be service impacting to any community. Additionally, that northern route, just by nature of it being northerly, when you think of the curvature of the globe, is the lowest latency route between the U.S. West Coast and Japan. And additionally, it allows us to serve the Unalaska market, Dutch Harbor, in the Aleutian Islands. And I think, you know, although the population in a lot of these places is very small, the market is very, very attractive. And to put that in context, the municipal government there is paying $32,000 per T1 of capacity per month. And I guess just the other thing to note quickly on the Trans-Pacific route, it's a different commercial structure than the Arctic route, where we will actually be selling spectrum as opposed to just lease capacity on the route. The other new development has been the addition of a branching unit and a branch going into Hokkaido, the North Island of Japan. And really that was a development that has come about because, you know, we've been approached by our Japanese partners to really add that capability in there to realize the ability to add an international route directly into Hokkaido, as well as to provide additional capacity into Honshu. And I guess some of the reasons why it is, in fact, important. The island of Hokkaido has a lot of green power, and especially after the nuclear incident, which has caused them to actually take a lot of the power out of the system, has made it very power-starved and high cost, which is one of the reasons why they're trying to shift a lot of the new data center development to Hokkaido. Additionally, it's an additional route that goes between the two, and Cloud Networks is going to build on the west side of the island to complete a new ring from Hokkaido into Honshu. And additionally, it's a catalyst to economic development. There's a new data center in Hokkaido, and there's several more of these planned, and the real, I think, constraint right now really is bandwidth coming to the island as far as further development of data centers. Doug mentioned spur going into Ireland. As you can see, we just come very, very close to the shore, and that was a pretty easy decision for us to actually add connectivity into Cork, simply because the cost of that route is relatively low, and the data center market there is extremely attractive and has been a big driver for us, as the number of big internet companies that actually have set up data center operations in there is quite numerous. The change to the landing points. We've moved from Mariama to Ajigawa in Japan, and this allows us essentially to remove several hundred kilometers of cable because we don't have to go south and then approach it again from the north, just due to the geology offshore. And in the UK, we've moved to Highbridge, which is a more northerly route, and it lengthens the wet portion of the plant, but shortens the actual distance of the route entirely, and shortens the terrestrial portion of the network. The other big change that we've had is really the phasing of the build schedule into 2 phases. The first phase completes the Arctic network, and the second phase completes the branches on out into Japan and the UK. And the seasonal windows that we have to work with the weather there and the available manufacturing capacity on the fiber side has really dictated that we break that up into 2 different phases to ensure that we can actually provide service on our 2 RFS dates. So this is just an overall timeline of the project, but I think the 2 key takeaways here are our RFS for the Arctic portion of the network is in Q4 of 2015, and our commercial contracts actually come to force January 2016. And on the international side, from the UK to Japan, October of 2016. Now, I think when it comes to private builds, it's really the sales that help to get your project financed and to ensure that you actually come to fruition. And that's the difference between the cables that make it and the cables that don't. And we've had a very, very successful year in our sales efforts. And we've begun actually executing contracts. And these contracts are lease contracts. Long-term infrastructure type contracts that range everywhere from 10 years to 20 years in length at a set price where the annual recurring revenue is known, which really provides the foundation for that financing. And our efforts have been very successful thus far. And without specifically quantifying it, it's tens of millions of dollars of revenue that we've already executed. And that in turn really takes us to the financing, where those contracts provide the backing for it. We've engaged Oppenheimer & Co., which is a leading middle market investment bank based in New York to complete the equity private placement for the company. The equity is the difficult component to put together, and we have the 3 other pieces of the financing, which are 3 different types of debt that will follow on after that, with the equity being that milestone. And those have all been provisionally secured. So we will have announcements within the next little while regarding the financing. With that, I'd like to just pass you over to Elizabeth Pierce, CEO of Quintillion Networks.
Thanks, Mike. Good morning, everyone. So it's been a really fast and furious year for Quintillion since we joined the Arctic Fibre project just over a year ago, and our focus is on Alaska. Alaska, as an Arctic economy, has some very similar characteristics to Arctic Canada, but some unique characteristics. Our economy is largely driven by the oil and gas industry and the federal government customer, a lot of defense spend and homeland security spend. As the Arctic opens up and there is more shipping and resource development activity, security and defense of the homeland becomes a greater concern for the federal government. And my good friend from Alaska Communications just shared with me this morning that he was at a conference earlier this year where the government announced a $12 billion spend in the Northern Pacific region, which includes Alaska, for defense and homeland security, which means that the timing of the Arctic Fibre project and Quintillion's efforts in Alaska are perfect for supporting that need for the federal government. Excuse me. So as Mike and Doug mentioned, we started off last year with landings at Prudhoe Bay, which is the center of oil and gas activity in Alaska, and the head of the Trans-Alaska Pipeline. We also had Barrow, Wainwright, which is now a major area of development for the oil and gas industry, with Shell announcing that they intend to restart drilling offshore in July of this year. Point Hope, where many of the oil companies have extended their exploration rights down as far as Point Hope. Kotzebue and Nome. And Point Hope was an add this year. The other add this year was Shimia, subject to federal government approval. Shimia is all a military installation. It's totally under the control of the federal government, and that would be the only customer there. So we decided not to proceed with the Dalton Highway build, as Doug mentioned, because AT&T is already building on the Dalton Highway, and in the market, there just isn't a need for two fiber systems along the same route. We can offer diversity to the market through the Arctic Fiber connections, and that better serves the Alaska market. Alaska has over 200 communities that rely solely on satellite backhaul, and cost of service is a major consideration. I was in Barrow this summer with Commissioner Pai from the Federal Communications Commission, and the library director announced that they pay $42,000 a month for 3 megabits of internet. So the federal spend in Alaska is pretty phenomenal in terms of subsidizing service, and of course that is something that is at risk for Alaska. So bringing in a fiber solution to these rural markets is an important factor. This map depicts the existing fiber network, which includes 4 cables that run from the Pacific Northwest into Anchorage, a new cable system that was built out to Southwest Alaska, a cable system that runs to Kodiak Island, where the main Coast Guard base is now, fiber networks up to Fairbanks, and then the new fiber being built to Prudhoe Bay, which is currently under construction. As you can see, that leaves a great deal of the Alaska market unserved by anything other than satellite. Our long-term goal is to build connections off these landing points with the cooperation of the Alaska Native corporations and the tribal entities to connect more of these communities that have been in these regions for millennia. The Alaska Native corporations are a very unique part of the Alaska market, and I don't know how many of you are familiar with Alaska Native corporations, so I'll just give a 2-minute primer. They were formed about over 40 years ago now, in the late 70s, when the federal government settled the Alaska claims with the Alaska Natives for land and traditional land use rights. And rather than just passing out a lot of money, they required the tribal elements to set up these corporations. They're organized into 13 regional corporations and over 200 Native corporations. Many of those corporations now, over 100 of them, generate revenues in hundreds of millions to billions of dollars annually. And they are some of the wealthiest and most productive businesses in Alaska. But they also, their shareholders, live in these regions, and they're very motivated to develop the economy of these regions. So what Quintillion is doing with Arctic Fiber in bringing this capacity to, or this capability to Alaska, has more meaning than just the commercial industry. Along that line, we've accepted 2 Alaska companies as equity investors in Quintillion, and one of those is one of the 13 regional Native corporations. We'll have a press release out later this week on that. We've executed capacity lease agreements, and we have more in final negotiations, and I'll say our capacity lease agreements first-year revenue are already exceeding our expectations. So the market is ripe for this opportunity. And when you look at examples like $42,000 a month for 3 megabits of internet, we really only needed to convert a good portion of the existing spend to justify this project economically. On the permitting and licensing side, TE Subcom is scheduled to visit this summer to finalize the landing site selection. Much of the civil works will begin in Alaska as well, as Doug mentioned. And we'll begin our landing license applications this spring once we get confirmation on some of the final landing site selections with TE Subcom. Everything is on schedule for permitting and licensing to begin the 2015 build. We talk a lot about risks in Alaska. We get a lot of questions about risk, and Doug covered a lot of this already. In addition to deadliest catch, and a couple of the Ice Road Truckers and a couple of the other shows. The one that worries me the most is Bering Sea Gold, where there are dozens of entrepreneurial gold miners off the coast of Nome digging 10 feet into the seafloor for gold. And so for that reason, the horizontal directional drilling is very important in Alaska, and it's in use and tested and proven by the oil industry around the coast of Alaska, especially the north coast of Alaska. So we feel very confident that this will adequately mitigate the risk of ice scouring and gold miners. The other risk that we get asked about is risk of competition, and as I said, it's largely satellite, some microwave, and the cost is so high that carrier to carrier, it's still thousands of dollars a meg. And we can compete on a much better cost basis than that and provide superior service. So we believe the market is very sound from an economic investment perspective as well as from a technology and delivery perspective. Last year I talked about the potential for a data center that is developing really well, and many of the dynamics that have driven data center customers to Scandinavia exist in northern Alaska. Natural cooling, low-cost green power solutions, and diverse connectivity, high-speed bandwidth, offering alternate routes to different areas of the world. We have two native corporations of the native corporations that have partnered in the data center, and the land acquisition is in process now. So it is very solid reality that this data center will be built. In addition, we're seeing a lot of economic stimulation in rural Alaska and coastal Alaska. We're consulting on 5 new projects that wouldn't be possible without high-speed broadband. And I can't go into the details, we're under NDA, but it is already 2 years in advance of being in service, significantly stimulating economic opportunity and new business in Alaska. We're looking again at additional connections from the landing sites to serve commercial and government customers, and of course the infrastructure support for the federal government and the agencies implementing the national strategy for the Arctic, which with some of the recent shipping activities through the Bering Straits has become a greater focus for the federal government. And again, a $12 billion spend on development, which we understand will include a new Coast Guard base in Alaska, in the northern part of Alaska. So the market is solid from a customer basis, from a contract basis. We're exceeding our expectations. The cooperation that we're getting in terms of selecting and getting through the permitting process is very encouraging, and we're on schedule to be ready for the ships to come with Arctic Fibre's build. Thank you.
Thank you. We have about 8 minutes left for people to ask any questions that they have of us. If not, get yourself another coffee or whatever. Yes, Heather.
Thank you. Sorry, I'm running between meetings, but maybe you've explained this before, but I know you're planning to carry some traffic that's within Canada or within the U.S. and some that's within North America and some that's international. So are those on separate strands of fiber, or how does that work in a domestic and international carrier environment?
I'll just take you back to the fiber routing diagram here. Essentially, we've got 2 fiber pairs that go directly from Asia to Europe. We've got 4 fiber pairs that go from Japan to Seattle. And then we've got 1 local fiber pair that hits all the local communities in Alaska and Canada, which provides all the domestic connectivity. It's not a festoon system. There's spurs coming off, so in the event that you lost 1 spur, it doesn't impact the entire local fiber pair. But that is essentially the design. So while the the fiber pairs themselves can transit, or the local fiber pair can transit international traffic, because it does go to the UK and to Japan, or after the Seattle spur is built into Seattle, it can provide both domestic and international.
Given where this is going and this whole idea of having sensors that can help with tsunami detection and also in terms of monitoring oceanographic conditions, with the Arctic being one of the most data-poor parts of the global ocean, I don't know what the company's been thinking about potentially getting involved in having sensors or sharing data from the system as it gets going.
I think what we provide is really the ability to provide to backhaul that data that is collected by those sensors from essentially any community that we hit on the map. In Cambridge Bay, they actually have a research fiber that goes undersea that videotapes the undersea aquatic life off of Cambridge Bay in the Arctic. And I think that, right now they have to actually physically send out that data back so they can look at it. They can't transmit it back. And what every single local landing that we have in the Arctic will enable is the ability to transmit all that data that is collected from ancillary systems that are laid anywhere across the network.
Let me just supplement that a bit. Paul, I think we're finding that there's a tremendous funding technology gap between the people that would want to check the salinity or ocean currents or tsunami warnings, whatever, and what they're prepared to commit for right now. And I'm very cognizant of the slide I think you put up there, or someone else put up there on Sunday morning, that showed the number of warning stations or tsunami recording places off the Aleutian Islands that have been inoperative for a year or more. And so we want to help out on that. But I think one of the key things from a economic perspective is, rather than have to put these on a long-haul network that is commercial network, it's going to be cheaper to actually build unrepeated systems into those various ports. Like Unalaska would be a hub to put out some sensors along that particular route. Or if somebody wanted to do something to measure the current in the Bering Sea or the salinity or the water temperature or what, they will go in and they will put in an unrepeated fiber of 38 kilometers or whatever, and they'll link it into our network at the Point Hope landing station, for example. So that's the way that we see it, as being able to meet that need and probably be more cost effective than trying to put a sensor underneath there and power that equipment from Seattle or Ajaguara or Cambridge Bay. So I think that's the way that we're seeing the technology evolve, and we're fully cooperative. We've had a lot of discussions with Ocean Networks Canada, the Canadian Coast Guard. I know the Quintillion people have had a lot of discussions with the Navy and the DISA people.
That's a great alternative to the long haul.
By the time you go and you want to rejig all those amplifiers every 53 kilometers, and power it. The power of the sensors is a major issue. It's cheaper and more effective to put it exactly where you want it to, because we may not want to go right on that fault line. We want to be located away from there. Yes, sir.
Well, it's mentioned that from the Japan to Seattle route is structured as a hybrid consortium and hybrid cable. So can you explain a little bit on that? So who are the consortium members for this particular segment?
Sure. I guess the two blue lines that go from Japan to the UK on the Arctic route are only available, or capacity is only available essentially by leasing. There's no IRU or spectrum sales. And on the Seattle route, essentially we're allowing the sales of IRU or spectrum on those individual fiber pairs. So of the 4 that come over, 2, maybe now 3, are essentially available to be purchased as spectrum, or we will be making IRU sales on those, which is more and that is, those sales are done essentially at the cost of the bills on a unit cost basis. So the ability to actually procure capacity from Japan to Seattle is there at the same cost that you would be incurring if you were part of a consortium. And the O&M cost is apportioned the same way on a per kilometer basis for that route. And the real driver for that is simply to prevent a glut of capacity to just be put onto the market without the demand to pick it up, which has extreme deflationary pressures on pricing.
Yes, sir.
Just a quick question around financing, because there was talk about the U.S. federal government for Alaska. There's been a lot of sovereignty debate in the media and the Canadian government. I'm sure they're aware of this project and they expressed interest for maybe billions of dollars.
Well, I think in Canada specifically, the federal government is the largest procurer of capacity in the north. And it is essentially, there's no contribution or no subsidy for this build from any government. There's a secondary phase to the build in Canada, which takes us out to, I believe, 23 or 24 communities total from our initial 7. That would require government subsidy in order to build to those communities. But for this initial build, there's no subsidy either on a capital or operating basis from the government. Yeah.
We would point out the Canadian government will be probably our largest customer. As of next week. Yes, ma'am.
Can you discuss a bit about backup? You're running fiber in a part of the world where you couldn't get a cable ship in to repair a fault for maybe 9 or 10 months of the year. What happens if there is a fault or some damage to the cable in the Arctic?
Yeah, I mean, the first two, I guess there's two aspects. The probability of an impact or a fault on the Arctic portion is extremely low, just due to the absence of most of the factors that cause cable cuts or something to happen to the cable. Whereas the riskier sections of the cable are in places where we can't get a ship easily. In the Arctic itself, even though it's a low probability, it's a high consequence if there is a break. In that instance, we've actually had to develop our own maintenance and repair plan to deal with a cut if, in fact, one happened. While a cut wouldn't impact any of the local communities in terms of the domestic backhaul, it would impact the transoceanic fiber pairs. In that instance, we have the ability, and we've had to develop a maintenance plan that essentially deals with that locally. So we actually have to station equipment and all the repair equipment locally in Cambridge Bay that we could actually airlift those different pieces of equipment to the break location. And if it's the time of year where there's an ice breakup, we actually have to get a ship in there. Other than that, we actually can go mobilize on top of the ice and hoist up the cable in that location. The mean time to repair is actually, in the winter months, going to be quicker because we can guarantee the time as opposed to have to wait for the availability and the location of a repair ship, because we're ourselves doing the mobilization for that, and we don't have to, and the resources are already pre-mobilized in the north. So you actually go on to the ice and hoist it up from there, and you create, I think, we call it the dog bone, because you've got the two ends where you're hoisting up, and then you have to cut in between so you can actually pull the cable across and lay it back down.
Would you tell your retailers that you provide satellite backup in that case? Or?
No. We're an unprotected solution for the domestic backhaul itself. We have the ability to take capacity either way. So if you get a cut anywhere along the network, it won't impact them. Because instead of taking it east or west, we just take it the other way around. And in that instance, we do provide protection from the UK or Japan back to back to either Montreal or Seattle, depending on which way it's going. For the international side, it's unprotected. It's for the carriers to develop their own protected solutions or mesh network. We're a single cable fiber, not a ring network.
We would point out that the probability of a break during the ice season in the Arctic, our ice-prone waters, is between 101 and 102 years, using all the standards, statistical basis that's been developed by the International Submarine Cable Protection Committee.
And there are over 20 cables actually that are in ice-prone waters, and not a single one of them has had a issue or break during the winter. The only one that actually had a break was Nuke, but that wasn't due to ice. It was due to an iceberg, which is a very different reason for that break.
Heather, something that you didn't hear is in most of the northern communities will be using horizontal directional drilling as they do in the oil industry, and we'll be burying the spurs like they do the pipelines that run off the north slope of Alaska. So the Endicott and the North Star pipelines that are 2.7 meters and have never had an issue and have been there for several years now. We'll follow that same model. If it's good enough for the oil industry, I think it's certainly good enough for us. So a big part of our focus is on building it right in the first place to minimize those risks, in addition to having a comprehensive repair strategy for all seasons.
And we do engineer it properly. I see we haven't acknowledged the most senior person in the world, Graham Evans, whose firm does probably 60% of the survey work, and we hope that they're going to be working on our project, and they will design and engineer something that is a permanent solution. We're doing it to the best world-class practices, and there's no sign-off from any of us if it's not going to last, period. Are there any other questions? If not, on behalf of the team, we thank you very much for your attendance today. As you can see, we've made fantastic progress. Our financing is coming into place, and we will be making some other corporate announcements within the next 5 or 6 weeks. And those on the international carrier side, if you're interested in one of the residual Pacific fibers, talk to Mike sooner rather than later. And on the regular Europe to Asia business, you can contact me, and we'll be able to talk to you about pricing and meet your demands. And I thank you all for coming. Stay around. We're going to be around. There's a little bit more coffee to be had. Thank you for coming. Bye-bye.